So we'll start by creating our Spring project, Spring JDBC minus demo. And then, yeah, it's going to be a Java project. It's going to be Maven. Everything else fits. Java level is 21 for me, but you guys are welcome to pick up 17 as well. And then we press next. Oh, yeah, I already have something there. Spring JDBC app. Next. Then, so dependencies I'll grab Lombok, just because I really like Lombok, and I'll show you guys, like, if you have never worked with Lombok, don't worry, it's super easy and fun. Then we grab the Spring Web. Of course, we do want something for JDBC, Spring JDBC, and we want, because we're going to be using Postgres, we're going to grab Postgres. Okay, so Lombok, Web, JDBC Driver, Postgres, and Spring Data JDBC. Perfect. Now we'll press Create, and off we go. So first things first, we grab a Shim SQL table. So we create a Shim SQL file for us to define our database tables. So this is just, an SQL file for us, which has our tables. This is just a student group table, just which illustrates one-to-many relationship. So one student group can contain many students, but each student can only have one group ID. And then we also have student table, course table, and student course table just for the many-to-many relationship. Yeah, perfect. Then we're gonna create a Docker file. Actually, no, I'm gonna do it here at root. And apparently I made a typo. Oh yeah, so Docker file, perfect. And we grab a Postgres image, then we do env Postgres user, which will be admin, and Postgres password, which will also be admin, and env Postgres DB, so our database name, which will be Spring JDBC minus DB. And we want to copy nicely created resources shim SQL file to the special folder entry point minus init db.d. And the idea is that, this folder is just automatically, so whatever file, SQL files here in this folder gets automatically picked up at the startup. Then because of that, it's our tables will be created every time the thing is started. So it's just a handy thing to have. Perfect. Now that we did all of that, we just set our all our properties here. So that Spring creates for us a data source. The data source bin just saves us work of defining it ourselves. So it's going to be Postgres for us, and then the URL to it is our host is localhost. We will just use the usual 5432, and the database is Spring JDBC DB. If I didn't type anything wrong, in Docker file it was defined as Spring minus JDBC minus DB. Yep. Then we have Spring data source username, which is admin, and then we have password, which is admin. Perfect. Now let's start our Docker file. If you're in IntelliJ, you can do right-click run Docker file. If you're not, I'll just show you an ID agnostic way, which is you literally just type the Docker command, and it's relatively simple. It's a Docker build minus T. The name of the database, JDBC. Actually, it's absolutely not relevant to the name of the database. I just like to tag. So it's just an image name. I tag my image with this name, and I just like to call it the same thing because for me it's Spring JDBC DB. And dot means look for the Docker file in the directory that I'm at. and which is a directory. And once it's built, I immediately run it in the same command. So I want to run it. The -d is for detach mode, -p is to publish the ports. So I'm just saying map internal Docker port of 5432 to the whole, like, computer's port 5432, so that we can reach it. And then I just say the image which needs to be run, and this image is the one that we just built. So this is our command. And just so I don't, oops, I lost it, but I like to just grab this command right away. Then I interrupted it because IntelliJ likes to override the Control C. Okay, yeah. So we just copy it, and I like to throw it here. So this is, I just like to delete all of this. We call it Spring JDBC DB, and then we say, Spring JDBC app, and then we say to run, start Docker, and this is it. Perfect. Oh, it's already running apparently. Docker container ls. Yeah, it's anyways. I actually managed to start it the first time. Docker logs 59. I just checked that it's actually up. Yeah, it's up and it's ready to accept the connections. Perfect. So we're good to go. And since it's started, we can actually use IntelliJ and immediately check. So I grab this URL. Then I go here and we go to Postgres. Yep. We paste the URL here and we just paste our admin username and password. We press test connection. Apparently I didn't specify something correctly. What could possibly be here wrong? JDBC, Postgres, sec, JDBC. Oh, PostgreSQL. Yeah, of course. Ah, there it is. So, again, admin, and then press test connection, and we're good to go. Cool. So we connect to this database. And as we can see, our tables are already all there and created. They, of course, don't have any data, but we didn't also want any data. We didn't expect any data yet. We just wanted to see that they're created. And yeah, so we're good to go. This is the folders we won't need. I'll just throw them out. Perfect. And cool. We can start with our domain layer. So we create a domain folder, and we will, pretty much, we just pretty much want to create a class per table. So one of our tables was called course, so that's what we're going to call it. Then we have a private long course ID, private string course name, private string course description. Exactly. So now we just need getter setters and stuff like that. For that, we can use data annotation from Lombok. It's super handy. And if we look here at view, tool windows, somewhere here, there's structure. Here we go. We can see that all these methods get all the getters, all the setters equals hashcode and to string. So all of these methods were generated by data. If I remove that, you see that all of that goes away. But with data, we have all of that. So yeah, it's very handy. But I also like to have all arguments constructor, and since all argument constructor would override the NORG constructor, I also define the NORG constructor. And now I also have these two constructors defined. So yeah, perfect. And just for testing purposes, I want one constructor without ID, because ID is often auto-generated, and perfect. Now in the same fashion, we create another class. This one will be student. Our student, again, will have a private long student ID, private long group ID, just to match all the fields in database, private string first name and last name. Perfect. And again, I just like to have a constructor without ID, and the rest I leave to Lombok. Add Norx constructor, add Orx constructor. Perfect. And now you can see why we like Lombok so much, because with Lombok we can literally just define only these few fields that we actually need to define, and we don't need all the boilerplate. Because if we were to remove this and actually create all the getters and setters, first of all we need to define this constructor, then we need to define select none constructor. Then we need to define all the getters and setters. And people like to say, oh no, why do we need Lombok? Come on, it just takes a few seconds. But yeah, look at how long our class got. And you got to read through all this boilerplate and try to find exactly what you want. But with Lombok, we just throw all of this out, and all we have is just few annotations, and we have, yeah, this is our class. I mean, it's this small. Just so neat. So yeah, I'm a big proponent of Lombok, but I do understand that it makes it a little bit harder for people who have not seen it to follow it sometimes. So private long student course ID. We technically speaking, we don't even need that ID because we can just use ID out of the other two fields like a combined ID, but doesn't hurt. So, and we add that data. And last but not least, we have a student group. No IDs. And it's our class. And here we also have some fields, namely private long group ID, private string group name. Perfect. And awesome. So now that we have our domain, I will also create DTOs because, in our controllers, I like to use DTOs. I don't like to expose. I mean, that's actually kind of the established way of doing it. You don't really want to expose your entities in the, to the outside world. You use DTOs to communicate. And the domain, I mean, the entities are only for the persistence layer. So yeah, and we want student DTO because specifically with a student, student like I mean, the student just doesn't look like how we defined it here. It doesn't have a group ID, it actually has a group, and it has many-to-many relationship with courses, which also have to be set. And I'll just do it all of here. So I will allow for the student ID because it's good to communicate to the user because they need to then we will then be doing HTTP requests and gets based on student ID. But other than that, we just need the first name, we need last name, and then we want to actually provide the list of courses that the student has, courses, and we want it to have a student group, right? And again, we will just do some convenience constructors. So I want to have a constructor with just these three fields. And I like to also allow for a static method called off, static factor method basically. And it will accept the student entity, student, and it will just return new, like the actual student DTO that gets, student dot get student ID, student dot get first name, and student dot get last name. So it allows just to quickly map the student entity into the student DTO entity. And of course, we don't want to forget our favorite three annotations, data, no args, all args. Perfect. So now that we've created our domain layer, let's start with our persistence layer. Cool. For that, we create a new package, repository, and we just start creating repositories in it. Or we start with course repository. There it is. And we just have to annotate with something. We annotate it with repository annotation. Just FYI, all the annotation service components and repositories, they are mostly semantic. So basically all are just annotation for Spring to know that Spring should use like these are Spring managed beans. And I'm saying mostly because repository does have a side effect because service and component are absolutely the only difference is semantic, but the repository also wraps all the exception into Spring runtime exceptions, all the SQL exceptions. So that's kind of a nice, neat side effect to it. And the only two things we'll need is private final JDBC templates, and private final simple JDBC insert. Now, both of these dependencies are come from Spring, but JDBC template will be configured for us automatically. So it's will get automatically configured from Spring, and you have to provide a constructor which specifies it, and Spring will auto-wire it. But simple JDBC has to be, we have to define ourselves. And you might wonder why, because Spring does have, the only thing it requires in the constructor is data source, and Spring does have a data source bean. And the reason for that is a simple JDBC insert requires configuration, and it can only be configured once during the instantiation. And you will see what I mean in a second. So we will not be having this. We will have a data source, and data source is indeed provided by Spring, so it will get hotwired. But then we will have to configure our own simple JDBC, and we do it just by providing that. And then we provide data source, and then we have to tell it which table name it should use. And in this case, the table name is course. And we have to tell it if we are using any generated column keys, and we do. And that's course ID, exactly. And because of that, Spring cannot just auto-wire it for us because these things have to be on an individual level. So we do create it here inside of a constructor. I just like it because constructor will naturally get the data source auto-wired, and then I don't have to, have a cert field here because I actually don't need the cert field. Cool. So then we will just specify our four CRUD operations. So create, that's course. And that one will just use a simple JDBC insert. But that's why we wanted it. And oops, execute and return key. Yes, that's actually correct. That's what I wanted. And I'll just use a map because it expects a map. Now, the only downside of using a map is this short form of creating a map does not allow null as values. And if I were to create a proper new hash map, it would have allowed me to have nulls. I'm just warning you. So if you get null pointer exceptions, you just have to switch to normal map. But I'm not planning to pass any null values, so I find it acceptable. So I'm just gonna use a short form. Let's just throw this here. Perfect. Maybe adjust it a little bit. Course name, and the second one will be course description and course.get description. Exactly. So that inserts it, and that also returns a key. That key, for whatever reason, is always integer. So we will just have to grab it as an int. I'll just grab it as an int. Yeah, int course ID. We will set that course set course ID, and it expects a long, so we can just but exactly because it's an object, yeah, that's why it doesn't work. And we just cast it to long here because yeah, it absolutely doesn't matter. And then we've got this. And then we've got the read update methods. Let's do those. Course read long ID return, and everywhere else except the insert we will just use JDBC template because it has some handy methods for us. So we have query for object, and to return a single object, and we write select all from course, so basic SQL, where course ID equals to question mark, and we will fill out the question mark. Now, as the returned object, Spring, not Spring actually, even like that's how Java works. Java JDBC or JDBC in general returns result set. And then you want to map this result set to your object course. And usually, you would like create your own mapper. And you can. So you can provide here the raw mapper. And if we take a look at the raw mapper, it's a functional interface with one method where you explain how to map when you get these two attributes to your type. So in our case, it would have been course, and I can totally do that. I can do something like this, and like do here new course. Give me a sec. Yeah, I mean, let's just provide the last ID. Yeah, just so we don't have everything red. And then we just do var course, return course. Why is it red? This is weird. I'm saying string, I'm saying object mapper. Ah, yeah, because it's two parameters. Result set and num of rows, I think, or row num was it? Row num. Yeah, that's it. Yeah, now it's happy. So it just couldn't match the overload. So yeah, I can just do this course, new course, and I can do something result set get, I don't know, it's a string, right? Get string, and the string is going to be course description, and this is totally a valid approach, right? And course name maybe here, course name, and we just set them inside of the course. Course set course name, and then course set course description. Yeah, and this is totally a valid approach. This will work. It will return here a course because of this mappers that we provided. Yeah, totally works. But there's a shorter approach, and that's what I'm going to use. And it's called bean property row mapper dot new new instance, and I just tell it which class, and it will do everything for me. Now, the reason this works is because in my case, the course class has the field names that match. Let me open this on the right, split right. So my fields match the field names used in the table, so the column names in table. So it's here with the underscore, and Spring is smart enough to figure out that the underscores get mapped to a camel case. And yeah, it just automatically, it's able to use getters and figure out, oh, okay, so there is a course name. I will look for something with course underscore name. And with that, it will itself do all the mapping. Now, if for whatever reason my fields were not the same in class, so for example, if I were to call this name, then that strategy would no longer work. So bin property row mapper would not find it, and because of that, it would leave it as null. And in my case, that's not the case, so I can just very easily use this because it's very handy. But if you happen to call your fields any differently than for the columns in your database, you will have to provide the custom raw mapper implementation like I've shown before. Cool. Then let's keep going. We also want to be able to delete by ID, and it's going to be JDBC template, template, update, delete from course, where course ID equals to question mark and ID. Cool. And yeah, that was the delete. And then I wrote one more method because in my controller, when I will be returning the student DTO, I want to be able to provide also all the courses of the student inside of the student DTO. So that's why I have here a little convenience method. It's called JDBC template query, and query returns us a list. And I'm saying select all from student course where student ID equals to we don't know what. And again, we have a bean property row mapper, new instance of a student course class and the ID. It's not happy with something. It doesn't know what student course is. From, right. Thank you. And we've got this, and we assign it to the courses, I mean student courses actually. student courses. Let me take this away so you can see a bit better. Cool. And then we will just stream through it and map it. We will say stream. We will say map every single student course entity to the course ID. Then we will map that into using this read, because here we have a method that allows us to read by course ID, and that will return us a course. And then we'll just map it to list. So easy breezy. And I just noticed that I forgot to write the update, so I'll do it now. So it is public void update course, and it will be JDBC template update. So first we just write our SQL update course, set course name, course description, where course ID, and then we just provide the arguments. So course get course name, course get description, course get ID, and that's it. Now we want to do the same for student repository, and since it's going to be relatively similar, I'm just going to copy this class and just adjust it to save myself some typing. So obviously here this table name changes to student, the ID changes to student ID. Everywhere where we see here course, we want pretty much students, so I will just do that. Replace, oops, not here, replace, this I will leave, replace, and oh yeah, this method we don't even need. So, and now we can just start manually adjusting. So, first things first, in create here, I sometimes, because I will check for some posts with students, sometimes I do want to allow some null values. That's why I'll just do a new hash map. It will be in var. Actually, yeah, I want to provide the type string of an object, params, right? And then I will put everything I need here. Put, for example, group ID that we defined to student. Oh yeah, it's called course, great. Student dot get group ID. And then we have the same for first name and last name. Let's get first name, get last name. Perfect. And yeah, because we already have all of our things defined, we just write params here. And then we, at the end, we just do, which this becomes a student ID. And we just set it into the student, set student ID. And we return the student. Perfect. Now we just want to do the read. It is select all from student table, where student ID is that. And this is correct, perfect. Then we want to do the update student. Set group ID, first name, last name, where student ID. And then we do all the arguments of a student. So first group ID, then student get first name, then student get last name, and then student dot get student ID. And here we have student, where student ID is equals to ID, and that is it for the student repository. So yeah, as you can see, it's relatively easy. Then we have a student group repository, so let's create that too. Student group repository, again, we just have a different table name. It will be group. And the ID is also group ID in our example. Yes, and here we will keep it simpler too. We will do int against it. So it's, yeah, let's just replace all of these. Starting from here, instead of student, it's everywhere student group. So replace, 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 replace. I'll just do replace everywhere. Cool. So we get a student group. Cool. And for the params, we'll just do map of exactly. And what does our student group have? Because I don't remember anymore. Student group has a group ID and group name, and we just want the group name. And here student group dot get group name, because we let the ID to be auto-generated, and set group ID group ID. Cool. That is done. Then for read, we do select all from student group, where group ID equals to this, and yeah, this actually will work for us. Then update student group, set group name, where group ID, and then it's just so student group dot group name is the first argument and group ID is the second argument. And here it's just group where group ID. And we're done. Perfect. Now that we're done with our REPL level, we can go to our controller and I'm going to create a package controller, and there we have, I'll create a student controller, and that's so, yeah, because I'm going to be doing my testing with this one. So it's a REST controller, of course, and we're gonna do request mapping, and give it a pass of student. Perfect. Now, I want to provide it all the methods it needs to be able to for the CRUD operations. So there are actually all the there are matching HTTP operations for the CRUD operations, for the create web post, for the read web get, for the update web put HTTP method, and for delete there's a delete method, and we will use all of those. So let's start with get mapping. To get, we want to allow to get by an ID, because ID is a dynamic variable. We will just write it like this, and then we will return the student DTO from here and get student by ID. So we will grab this dynamic variable with a special Spring annotation called pass variable, which will automatically map this ID to the variables that I have here. I'll use long ID, and then it's very simple. I want to return it from my repo, but the controller should not communicate directly with the persistence layer. There should be a service layer in between. So let's actually quickly define service. Student service. It doesn't exist yet, but we'll define it in a second. And then we say student service get by ID, right? And we'll provide an ID. And I'll just finish writing the methods, and then we'll go and create the student service, right? So then we have a post mapping, and we don't need any parameter, any pass variables here. But we will accept, so it will also return a student DTO. It will create a student, and it will accept a request body, so basically a JSON, with which it will map to the student DTO, and then it will create it. So we'll just write something like student service dot create student DTO, right? And we actually want to return it so that the creator has an ID. Then we have update. For update, it's relatively similar. We again want well, same line, and then we want student service to update our students, and we will just return. Actually, we'll just return HTTP status here. HTTP status, where is it? No content. That's our confirmation that it's been created. But you know, we don't need to return anything. And then we have delete mapping, which also accepts a dynamic variable of an ID. Do public HTTP status, delete student. Again, we use a pass variable to grab that ID. And then we say student service, delete by ID, and then we return HTTP status, no content. Cool. Now we gotta take care of our student service. Let's create this class. We will create in a different package in service package. Perfect. And of course, it's going to be at service, and we'll require quite a few repo classes here. So we will obviously need the student repository, but also I will want to provide the courses that student has, so course repository. And last but not least, I also want to provide the group to which it belongs, so I will also grab that one. And because I want to auto-wire all of this, I will use required args constructor, which will automatically create a constructor matching all the final fields. And because it's the only constructor, Spring will use it to auto-wire me all the dependencies. So yeah, nice and easy. So let's start one by one. We had a, actually let's do it like this. I just go here and I will do the methods here. Oh, and here I also have to have a add required args, right? To auto-wire it here too. And yeah, let's just create methods from here. So I'm just saying, please create a method for me, cool. And we will do it like this. Student equals student repository get or read ID, right? Once I have that student, I will do course repository, find by student ID, and then I will provide the same ID. And those are my courses. Then I want to use student group repository to get the group. And we take it from the found student and we get the group ID. And that will be our student group. Perfect. Now we can create a student DTO of the student that we've read. So that gives us most of the fields. But we also want to set courses as courses. And then we want to set the group. What's a group? And then we return the student DTO. So yeah, that was a read. And all the rest of our operations are even easier. But yeah, again, let's just look here and let's just create them. So I want to create. And here we just do student repository, create, student. Yeah, and I need to provide a student. So let me just do that. New student, and I'll just map student DTO right here. Get student ID, student DTO, get first name, student DTO, get last name. Cool. And let's just return it, right? Oh, but we don't want to return it, so because we want to return student DTO, student. So let's just do student created student, something like this. Then I do return student DTO, and I use my helpful method off, which will just automatically map it for me. So yeah, that's awesome. Then we have an update method, again, same story. Then we do student repository, update, no, update. And again, it expects a student, so I'll just use this. Oops, perfect. And I just need to get rid of these, awesome. And last but not least, we have delete by ID, so there we go. And this is super easy, student repository, delete ID. And that's how easy it is. Cool. So we've created our student service, and I would say we're ready to test. So let's go for it. So now we start by opening Postman, and yeah. So for now our database is empty. So let's make the post request to student, And as a body, I'm just gonna, send something, John Murphy, whatever. We send it, we get the student ID, so student ID of 3, John Murphy, exactly. He has no courses, no, he has no student groups. And just for us to be, yeah, we can take a look here in database and we see that exactly it exists here. And for us to be easily able to test stuff, let's just, create some test data. So we don't have to create controllers for every single one of these things. Let's give this, I don't know, some ID, 20, group name, student group name, whatever, Gryffindor. We send it, perfect. And then we go to our favorite student and we give him the same student group. So yeah, now he is part of this group. And also let's do some courses. Again, we do some course ID, I don't know, 29, course name, gender studies, course description, pronouns. Cool. Seems to be a hot topic. And now that we have this course ID, we just grab it, we go to student course, and our student's ID was, oops, no, that's not what I wanted to do. Yeah, I don't want to do anything. So we have student with a ID 3, and we have course with an ID 20. So I can open this, I can do some random thingy, and we're good to go. So now our student with an ID 3 has a course of 29, which is here, and that is good to go. Perfect. So now our student has all the data for us to be able to do our testing. So when we go to get the student, we actually, yeah, that's non-existing ID and we didn't handle the scenario. But yeah, for an ID that we do have, what is this? And exactly, we can also take a look at what actually happened. I'm assuming it said incorrect, yeah. So I tried to query for it, but the ID was non-existent. Um, the simplest solution is just to catch this exception and return, for example, 404. Let's do that. So we have, that part also covered. We can, well, maybe we'll do it in service, right? Or where do we do it? No, let's just do it here. It's just gonna be easier. Catch, just so you guys know how to handle something like this. So we catch this exception, and if this exception shall happen, we just return. We can also just return, we can wrap it in a response entity if we feel like it, but um, yeah, I mean, the only way to deal with it would be actually to wrap it in the response entity. So I'm just gonna show you guys how to actually deal with it. And then it would have been something like response entity and something like okay. So here we wrap it in the response entity, and here we do not found. What does it want from me actually? Just want a body or something? Build. Ah, yes, that's it. So now if we try to access, I'm just gonna restart the application. And now when we try to access some ID that doesn't exist, we just get 404 not found, which is what we should be getting. And for an ID that we do have, we get a proper response. And if you want to update, for example, this guy, this student John Murphy, let's just update him into, yeah, let's just do that. Let's do him, that's his ID. Let's do him Mr. John, and I don't know what else is fun. Wick. And his group ID, what was his group ID? I forgot. His Gryffindor. Yeah, that just stays. Oh, it's 20 now. And yeah, my test, yeah, that was from my old test. So I just send this. I have now, yeah, breakpoint. Let's just allow it. And we get now content. But now if we look at the student, he will no longer be, what was it, John Murphy or something. It will be Mr. John Wick, which is what we were expecting. And if we feel like we're done with the student, we can just, feel free to, what's the student ID again? 3. We can just do this and we delete it. And if we take a look, there is no longer that student. So there you have it. That's how we can, implement everything with Spring JDBC. Hope you learned something, and see you next time.